Alright, Unit 7, Probability. We're starting a new unit here. And 7.1 is the video for today, Permutations and Combinations. Alright. Go ahead and copy this down. So we have the fundamental counting principle. And basically what it says is if you have A, B, and C, by the way, are numbers. So A, B, and C are just numbers. But if you have A ways of doing event 1, B ways of doing event 2, and C ways of doing event 3, then the total number of outcomes is A times B times C. And I put here, this idea can be extended to any number of events. So if you have just 2 events, you just multiply the 2 numbers. If you have 10 different things, multiply all 10. Now I'll show you what this means by events and all that. It might not make sense at the moment, but the idea is we're multiplying all the possible ways. So, for example, you have 3 shirts, 2 pairs of pants, and 5 pairs of shoes to choose from for your math party. How many different ways can you make your outfit? So, what we do is we recognize that, well, you have 3 shirts, you have 2 pairs of pants, and you have 5 pairs of shoes. So, what do? You just take 3 times 2 times 5. Multiply them, and that's your answer. 3 times 2 is 6. 6 times 5 is 30. So, again, what that means is, let's say, okay, you have 3 shirts. The first shirt you choose can go with 1 pair of pants and 1 pair of shoes. But that same shirt you just chose could go with the other pair of pants and then one of the other pairs of shoes. And you have all these different combinations. So you have a total of 30 different ways to match your shirts, your pants, and your shoes for your awesome math party. Okay, here's another example. This one is actually a little more detailed, so we want to read it carefully. It says, in Utah, a license plate consists of 3 digits followed by 3 letters. The letters I, O, and Q may not be used, and each other letter or digit may be used more than once. How many license plates are possible? So let's think about how many letters are in the alphabet. So there's 26 letters, but we cannot use 3 of them. So right at the moment, we only have an option of 23 letters. Okay, because we can't use those 3. And then how many digits are possible? The digits are 0 through 9. So if you think about it, if you have the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, how many digits is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 possible digits. So just be a little careful there. Now let's think about how we're gonna figure this out. Think about like this. You have a license plate that says 3 digits followed by 3 letters. Let's go ahead and for each of those, we're gonna make a blank. So the first blank is the first digit that you can have. The second blank is the second digit. This is the third digit. Then this is the first letter, second letter, and third letter. So this is how your license plate would look, with whatever combination of letters and numbers that you have. So the first one has any possible digits. Well, how many digits are there? There's 10. So there's a total possible number of 10 digits here. So we're going to put a 10 here. Now, because we're allowed to repeat digits, how many possible digits can I put here? Another 10. And here, it's another 10. So 10 digits possible, 10 digits possible, 10 digits possible. Then we have the 3 letters that we can have. And, like we said, we're limited to 23, not all 26, because what we said before, we can't have I, O, and Q. So for this part of the license plate, we can have 23 possible letters, and that's true for these as well. Well, by the fundamental counting principle, you just take these numbers and you multiply them. So this one I cannot do in my head, so we're going to get our trusty calculator out. 10 times 10 times 10 times 23 times 23 times 23. And so this is how many license plates are possible with this criteria. So there are over 12 million ways to do that. By the way, you could have also typed this in your calculator as 12 cubed, so 12 caret 3 times 23 caret 3. And you would have gotten the same thing. because that's how exponents work. Go ahead and copy this down real quick. So we have factorials. So this is read as, in fact, we should write this down. This is read as n factorial. N factorial. And all it means is, if you have n factorial, you can rewrite this as that number times that number minus 1 times that number minus 2, and so as far as you need to go, and then it should end with times 3 times 2 times 1 if your n value is bigger than 3. And then by definition, 0 factorial is equal to 1. So if we ever get 0 factorial, it's just 1. And so you should definitely make a note of this if it ever pops up, which it may. So let me show you how to do factorials real quick. It's actually very easy. 4 factorial is 4 times 3 times 2 times 1. Again, notice that we ended in 3, 2, 1 like the definition said. So we just multiplied 4 times 3 times 2 times 1. We get 24. Let's try 6 factorial. What is that? That's 6 times 5 times 4 times 3 times 2 times 1. That's 720. There is a factorial button on this calculator. I'm going to leave that as a little exercise for you to find it. So I'll let you try and find that out yourself. 1 factorial. Now 1 factorial is just 1. Because I'm starting at 1, but I have to end at 1. So it's just 1. Let's also do these. We have 7 factorial divided by 5 factorial. I mean, you could do that in your calculator, but you need to know how to do this by hand. So you need to know how to do this by hand. So basically showing work. So here's a little trick. And let's see if this makes sense to you. If I expand 7 factorial, kind of like how I did these, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. But couldn't I also do it like this? And I want you to think about this. I can write 7 factorial as 7 times 6 times 5 factorial. Why does that work? Because think about what 5 factorial is. 5 factorial is 5 times 4 times 3 times 2 times 1. So I don't need to expand the whole thing. But why would I stop at 5 factorial? Well, look at what's on the bottom. There's a 5 factorial on the bottom. So if I stop here and then I bring this over because it's still there, what do you think happens here? They cancel. They're gone. 7 times 6 is left over on top, which is 42. Let's try that again. Now, the bigger factorial is on the bottom of the fraction now. It's in the denominator. So how about I keep 4 factorial on top as it is, but I'm going to expand this into 8 times 7 times 6 times 5 times 4 factorial. And see, if I stop here, I can cancel these out. Now, what do we have left? Well, because I canceled this out, I have a 1 left on top. On the bottom, I just do 8 times 7 times 6 times 5. It's a little too early in the morning to do that in my head. So, get 1680. So, because of bigger factorials on top, that's why it's 1 over a number. On this example, the bigger factorial 7 was on top. That's why it's just a whole number, not a fraction. Okay? So let's see why factorials are needed in probability, and here's why. Go ahead and copy this down. So you have permutations and combinations. You use these to find the number of ways that a number of objects can be taken or arranged at a time. For permutations, here's the formula. This is read as NPR equals n factorial over n minus r factorial. You use permutations when the order of things you're trying to arrange matters. Combinations, this is read as NCR equals n factorial divided by r factorial times n minus r factorial. You use combinations when your order doesn't matter. When you're with whatever you're taking. Now I'll tell you what N and R stand for, and this is very important that you realize that N is the number of objects you have in total. So it's the total number of objects you're choosing from. And then R is the number of objects you're actually choosing. So these are really important to keep in mind as we go through these word problems. So let's go ahead and let's do an example. Oh my goodness, it's upside down. Here we go. All right. Example. How many ways can a club select a president, a vice president, and a secretary from a group of 5 people if they are selected in that order? The first question you should ask yourself when doing permutation and combination problems is, does order matter? And if you read right here, it says if they are selected in that order. So guess what? Order matters. Order absolutely matters in this problem. So that means we're using permutations in this problem. Now, let's go ahead and identify what is N and what is R. So N is the total number of things you're choosing from. In this case, you're choosing from 5 people. So N is equal to 5. R is how many people you're choosing. Well, you're choosing a president, a vice president, and a secretary. So how many people are you choosing in total? 3. So the way we do this, if we do the formula that you just copied down for permutations, is 5p3 equals, and then on top of the formula, we had n factorial, so 5 factorial, over parentheses 5 minus 3 factorial. So I'm just plugging in for n and r. Now, order of operations still applies, and 5 minus 3 is 2. So 5 minus 3 is 2, but it has a factorial sign after it, so it's 2 factorial. Now, just like I showed you before, let's expand the bigger factorial until we get to the small factorial. Like this. So these cancel. And then we just have 5 times 4 times 3. 5 times 4 is 20, times 3 is 60. So there's a total of 60 ways to choose 3 people from a group of 5 if the order matters. Example. Zoe is going to adopt kittens from a group of 11 kittens. How many ways can she choose a group of 3 kittens from the litter? So again, the first thing you have to ask yourself is, does order matter? So think about this for a moment. See if you can determine from the wording, does the order matter in which she chooses these 3 kittens? So the answer is no, the order does not matter. Order doesn't matter. But why? Because if she picks kitten A, kitten B, and kitten C, as long as she has those 3 kittens, that's all she cares about. She doesn't care the order that she picked them in. See, that you just got to be able to think in that way. So we're using combinations in this problem. Let's go ahead and identify N and R. So N is the total number that we're choosing from. Well, we're choosing from 11 kittens. R is how many you're choosing, and you're choosing 3. So we have our N and R values. We're using combinations, so we're going to do 11C3 equals, now the formula has n factorial on top, so it's going to be 11 factorial. Now this one had 2 things on the bottom. It had r factorial, so it's going to be 3 factorial. And then times n minus r factorial, which is 11 minus 3 factorial. Well, order of operations, let's do our parentheses first. So I have 11 factorial still on top. I have the 3 factorial on the bottom still. 11 minus 3 on the inside is 8 factorial. By the way, and maybe make a note of this, I'm not going to write this down, but you cannot multiply 3 times 8 if they have the factorials on them. So don't try to do that at all. 3 times 8, do not do that. What we need to do instead is expand the biggest factorial that we see, which is 11, down to, let's go down to 8, and you'll see why again. 11 times 10 times 9 times 8 factorial all over 3 factorial times 8 factorial. What happens with these 8 factorials? They cross out. Now, we still have a 3 factorial, so can we do this real quick? What is 3 factorial? It's 3 times 2 times 1. Now, think about this. Can I reduce 3 and some other number here? Yeah. 3 and 9 can reduce. So, if I divide 3 by 3, I get 1. If I divide 9 by 3, I get a little 3 here. So this 9 becomes a 3. Can I do the same thing with the 2? Yeah. 10 and 2 have a 2 in common. If I cross out a 2 here, I'm down to 1. 10 divided by 2 is 5. So what am I left with on top? I have 11 times 5 times 3. On the bottom, I have 1 times 1 times 1. But if they're all 1s, this doesn't matter anymore. So what am I left with now? 11 times 5 times 3. And if we calculate that, for some reason I'm just not able to do this in my head today. If we do 11 times 5 times 3, we get 165. Okay? One last thing I want to show you just real quick, if you want to copy this down. I just want to go into why, what's the difference between permutations and combinations. Suppose you have 3 objects. You have this object, and this object. A, B, and C. What does it mean to have permutations and combinations? So remember that with permutations, order matters. So if I said, give me all the possible 2-letter permutations, well, that would be AB, BA, that would be BC and CB, and that would be AC and CA. Because each one of these are considered different because the order matters. Even though, like for example, these two contain the same letters. They both contain an A and a C. But they're considered different because the order is different. So if I said, give me all the possible 2-letter combinations, all you could give me is AB, AC, and BC. Because if I try to put BA in this list, because order doesn't matter with combinations, I already have BA taken care of right here. So I don't want to put that in my list. So that's the difference between permutations and combinations. Order matters, order doesn't matter. Alright, so we're done with this video. And I think I'm supposed to shout somebody out. I know Aziza, so there you go. And there's some other people in period 1, so there you go. I don't have a math joke. I'm so sorry. Please forgive me.